investor, not financial advice.
Starship Flight 14 could cross the line that every previous integrated Starship test stopped short of crossing: a sustained orbit around Earth. That does not mean the mission has already launched. It does not mean the vehicle is operational, and SpaceX has not published a firm launch date. But the hardware campaign has moved into a new phase. Ship 41 has completed 2 important ground tests. First came a single-engine firing that SpaceX described as demonstrating a deorbit-burn for upcoming orbital missions. Then the vehicle completed a full-duration 60-second static fire using all 6 Raptor engines. Those tests do not prove an in-space restart, orbital insertion, or safe return. They do show exactly what SpaceX is preparing to attempt next. Why does one more test flight matter after 13 launches? Because orbit changes the job. A short suborbital trajectory can test ascent, staging, re-entry, and landing. A true orbital mission has to manage a longer coast, spacecraft power, communications, thermal conditions, guidance, propellant settling, engine commands, and a controlled deorbit plan. It turns Starship from a giant flight test vehicle into the early version of an orbital transportation system. Today, we will separate what SpaceX has confirmed, what reporting suggests, and what investors should actually watch. Flight 14 may be the most important Starship mission yet, but the real milestone is not the word orbital. It is whether the entire chain works together. Start with the ground campaign. Ship 41 is the upper stage expected to fly on Flight 14. On August 19th, it performed a single-engine static fire lasting roughly 15 seconds. SpaceX said the test demonstrated a deorbit burn for upcoming orbital missions. The next day, the ship fired all 6 engines for about 60 seconds, a full-duration test that exercises the propulsion system under a much larger thermal and mechanical load. The distinction matters. A ground firing can validate valves, ignition timing, thrust behavior, control software, and the integrated plumbing on this specific vehicle. It cannot reproduce weightlessness, propellant behavior after a long coast, vacuum conditions, or the exact thermal state of an orbital spacecraft. Flight 14 must still prove those pieces in the environment that matters. There is also no confirmed launch date. Current reporting points to a possible early to mid-September attempt, but SpaceX still has vehicle preparation, stacking, range work, and regulatory steps to complete. Treat every date as a planning estimate until SpaceX posts an official launch target. This is the right way to read the tests. They reduce uncertainty, but they do not eliminate it. The single-engine firing is evidence that the team is thinking beyond ascent toward a deliberate end-of-mission burn. The 6-engine firing is evidence that the flight article has cleared a major propulsion checkpoint. Neither result is a substitute for orbit. That is why Flight 14 exists. Previous Starship flights reached space and approached orbital energy, but they followed trajectories designed to return without completing a sustained orbit. Flight 14 is expected to go further. Once a spacecraft reaches a stable low Earth orbit, it does not simply fall back on schedule. SpaceX must control when and where it leaves orbit. That begins with reliable insertion. The ship must reach the intended velocity and trajectory after stage separation. It must then survive an orbital coast while keeping avionics, communications, power, navigation, and thermal systems inside their operating limits. Liquid methane and liquid oxygen move differently in microgravity, so the vehicle must establish the conditions needed for a commanded engine start. The deorbit burn then has to occur at the right time, with the right duration and direction, to place re-entry inside the planned corridor. This is also a safety story. The FAA's current environmental work describes contingency landing areas along nominal orbital trajectories and an additional path back toward Starbase. That does not mean every option is approved for Flight 14. It shows that orbital Starship operations require a larger safety architecture than a short test corridor. For investors, orbit is the first time duration becomes part of the product. Starlink deployment, on-orbit maneuvering, propellant transfer, lunar missions, and future compute payloads all require a spacecraft that can operate predictably after ascent. Flight 14 cannot prove all of those businesses. It can test the operating foundation they share. The likely Flight 14 architecture is more disciplined than the most aggressive version discussed after Flight 13. Reporting now indicates that Ship 41 will probably finish with a controlled ocean splashdown rather than attempt the first upper stage tower catch. Super Heavy may also target an ocean return. SpaceX has not yet published the final mission profile, so those recovery details remain provisional. That is not a step backward. A first orbital attempt already carries several new variables. Removing an immediate return to launch site catch can isolate the orbital objectives and reduce the number of unproven events that must succeed on the same day. The company can still gather re-entry, heat shield, control, and landing data from an ocean return. The success ladder should therefore have 5 levels. Level 1 is clean ascent and stage separation. Level 2 is orbital insertion. Level 3 is stable spacecraft operations during the coast. Level 4 is a commanded deorbit-burn that places the ship into its planned re-entry corridor. Level 5 is controlled atmospheric return and a soft splashdown. A partial mission can still generate valuable data, but do not let a dramatic launch obscure the sequence. If the ship reaches orbit and later loses control, that is different from completing the full orbital cycle. If it completes the cycle but is damaged during re-entry, that is different from demonstrating a reusable spacecraft. Flight 14 should be judged event by event, not as one binary success or failure. The most immediate business reason to take Starship Orbital is Starlink. SpaceX's prospectus says each planned V3 satellite is designed for 1 terabit per second of downlink capacity. The company expects a mature Starship launch to carry as many as 60 of them, potentially placing about 20 times more Starlink downlink capacity into orbit than one Falcon 9 launch. Those are design targets, not a promise for Flight 14. The mission's final payload has not been officially published. The investor takeaway is the direction of travel. Falcon 9 can deploy the current network efficiently, but the largest V3 satellites were designed around Starship's volume and mass. Until Starship becomes a dependable orbital carrier, a major part of Starlink's capacity roadmap remains linked to a development program. Orbit is therefore the bridge between a vehicle milestone and network economics. A successful insertion can validate the basic delivery path. Future missions then have to prove reliable deployment, satellite activation, higher payload counts, and cadence. Only after those steps can the theoretical 20-fold capacity advantage become useful capacity serving customers. There is an important nuance in SpaceX's own filing. Full upper stage reusability is not required to begin deploying V3 satellites in low Earth orbit, and in-orbit refueling is not required for those LEO missions. SpaceX could create meaningful connectivity value before it solves every reuse challenge. That makes first orbit commercially important, even if the ship is not yet caught or reflown. Now for the most important reality check. Orbit is necessary, but it is not the economic end state. SpaceX designed Starship to return both stages, inspect them quickly, and fly them again. The prospectus describes a V3 target of 100 metric tons to orbit in a fully reusable configuration and an ambition to reduce launch costs dramatically. Those numbers depend on operations that have not yet become routine. The difference between recovery and reuse is time, labor, and reliability. A ship can survive re-entry and still require weeks of tile replacement, engine inspection, structural checks, and software review. It can be caught by a tower and still fail to fly again economically. The metric that matters is not simply whether hardware comes home, it is how much refurbishment it needs, how fast the same vehicle returns to the manifest, and how performance changes across repeated flights. Flight 14 can advance that curve in 3 ways. It can return better heat shield data from a full orbital re-entry. It can demonstrate that the vehicle retains control authority and propellant margin after a longer mission. And it can give engineers a clean comparison between ground test predictions and real orbital behavior. The bull case is that orbit unlocks a fast learning loop. Fly, recover data, modify, and fly again. The bear case is that each orbital attempt reveals expensive new constraints. Investors should celebrate the milestone without confusing one orbital mission with airline-like operations. Flight 14 also sits underneath SpaceX's lunar ambitions. NASA selected Starship Human Landing System as part of the Artemis architecture, and missions beyond low Earth orbit require capabilities that a suborbital test cannot demonstrate. A lunar Starship must operate for much longer, dock, receive propellant, manage cryogenic fluids, and execute precise burns far from Earth. SpaceX states that in-orbit refueling is not needed for its LEO Starlink programs, but it is intended for lunar and interplanetary transport. That creates a clear development ladder. First, reach orbit reliably. Second, operate and restart engines in orbit. Third, bring 2 vehicles together. Fourth, transfer propellant. Fifth, repeat the process with enough cadence and reliability to support a lunar mission. Flight 14 addresses only the beginning of that ladder. It does not demonstrate orbital refueling, a lunar landing, or crew safety. NASA's Inspector General has already warned that lander development challenges are pushing Artemis schedules. That is why every Starship orbital milestone matters, and why none should be exaggerated. If Flight 14 completes insertion, coast, and deorbit as planned, SpaceX will have a more credible platform for the next tests. If it falls short, the failure point will show which part of the chain still needs work. Either outcome produces information. Only repeated success produces a transportation system. Here is the Flight 14 scorecard. First, watch the official launch target. Ignore recycled dates until SpaceX and the range publish a real window. Second, watch ascent and stage separation. A new orbital profile still depends on the fundamentals. Third, confirm whether the ship actually enters a stable orbit rather than merely reaching space. Fourth, watch the coast phase for power, communications, and attitude control. Fifth, look for a commanded deorbit-burn and accurate entry into the planned corridor. Then watch the return. Tile loss, flap control, engine performance, and splashdown precision will tell us more about the reusable vehicle than the launch spectacle alone. Finally, watch what happens after the mission. How quickly does SpaceX inspect the data, prepare the next ship, and move toward recovery and eventual reflight? The central investment idea is simple. Flight 14 could turn Starship from a vehicle that visits space into one that begins operating in orbit. That would not complete the Starlink V3, lunar, Mars, or orbital compute thesis. It would connect those ambitions to a real transportation architecture. My base case is a successful orbital attempt with an ocean return and a long list of improvements before upper stage reuse. The upside case is a clean, full cycle that accelerates payload missions. The risk case is a problem during insertion, coast, or deorbit that exposes another schedule bottleneck. Which result would change your SpaceX thesis most? Orbit, payload delivery, recovery, or reflight? Tell me below and subscribe to SpaceXInvestor. This is analysis, not financial advice.